Hey, what's going on, guys? And today we're going to be going over a little bit more of our own custom physics engine. Obviously, it's not like, it doesn't have a lot of application outside of Unity, but for our purposes, this physics will it'll encompass what we need it to do. So if you go into our enemy collision, which is in here, check collision. This only does the player collision. So what we're going to do, just to clean this up a bit, we're going to cut all of this out from here. And we'll do check player collision. Whoops. And then we'll go ahead and generate that default method and paste that in there. So the reason we do this is because if you remember at the very beginning here we say if our player equals null, so if there's no player, then we're going to return, which means that none of this gets called. So if we go ahead and, down here add in the next collision stuff, that collision will never be processed if the player is null, and that's why we want to do two separate checks when we do our checking for collision every frame. So we could make a new method here, but I'm going to try and encompass everything inside of this method right here, so we don't need to waste any more space. And so one way we could do this, obviously there's other ways we can do things like the built-in collision, but I like to do things my own way sometimes just to see what I could accomplish. And so what we're going to do is check to see if we didn't move the last frame. And if we didn't move, it means we're stuck, and that means that we're colliding with something, which means that we want to either switch direction or jump. So the first thing we'll do is if the distance between, we'll do the absolute value between transform.position.x minus last x position. We don't have that yet. We'll create it in a minute. If that is less than the distance, we don't have that yet either, then it means we're stuck. So first, let's go ahead and make this last x position here. We'll make a private float last x position, and then in our update function, here's where we calculate the motion and jumping, and then after that we do the check for collision. So in here we're going to do, after the check collision, we'll do last x position equals transform.position.x. Okay, and so what this means is it'll update its x position, and then the last x position, which was the same from the last frame. So in between this move, the x position is different from our last x position because it doesn't get updated until after we check the collision. So it's basically an update after the frame where we do this collision check here. Alright, and then the next thing we're going to do is make this distance here, and we'll do that up here because we don't, well, just for the sake of keeping it efficient. Obviously, I'm trying to throw this whole efficiency thing onto you guys in these past few videos, but we'll make a new private float distance, and then in our start method here, we're going to calculate the distance, and so we'll do distance equals, and before I do that, if you guys haven't learned this in math yet, shame on you, speed equals distance divided by time. So we're going to do distance equals speed times time. So the way we're going to do time is we'll do speed times time dot delta. Okay, I changed my mind. Just because how computers work, the time in between frames is going to be different every frame. So it would actually be better to, it's not really wasting resources because it's for a good reason. It's to keep these checks accurate because the distance traveled each frame, it should be different. So we'll do this up here, and then we don't need this in here. We don't really need need this to be global anyways. We could just keep it inside here, but just because we've already done it, I'll keep it that way. So what this does is every frame it'll calculate the distance it should have traveled, which is the speed times the time passed in between last frame. So this is the distance it should have traveled to the last frame, and then it checks if the distance we actually traveled is less than the distance we should have traveled, then it means we're stuck. And so we'll do we will do if get random bool. Actually, we'll do unlikely. Then we're going to jump else speed equals negative speed. Okay, now obviously we haven't had this jump thing in here because our jumping really was just was in here. So we're going to go ahead and cut that and do jump here as well. And we'll do a new method called jump, and in here we're going to do that the jumping. Okay, now let's go ahead and give it a go. I'm going to pause the video for a second while I load up Unity. Alright, we're here. I'm going to take this spawner real quick, and I'm going to make its minimum spawn delay 0.5 and its maximum we'll make it 2, just so it spawns up really fast. So we can go ahead and see if this collision is working. We'll turn him around. Okay. So the reason that if you notice it like turned 2 times, that's because it turned once because it calculated we hit ourselves, and then it turned a second time because it calculated a hit it wasn't moving. So we need to do this check player collision only if this if the check player collision returned false. So we'll instead of a void, we'll turn this to a bool. So now we'll return true if it hit the player or false if it didn't. So in here we'll do return false, 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 and then at the very bottom here we will do return false. Now inside here we're going to do return true. Okay, so this means that if the player is doesn't exist, return false. If the player is grounded, or if we're in the air and our y is greater than our own height, then we're going to return false as well. Or if we've already hit him this frame, return false. Else, if everything else works, we can move our direction, set our last hit, do the damage, and return true because we did hit the player. Else, we're going to return false. Alrighty, so then inside of our check collision, we'll do if check collision returns true, then we're going to return. That means if we already calculated a collision in this frame, we're just going to return and not do any of this stuff here. So now let's go ahead and give that a go. Okay, let me change this to 3 and then 1. So you can hit us, and it's still not working the way we want it to. If this doesn't work this time, then I'm gonna go ahead and find out what's going on here. So let's go ahead and put in some debug. We'll do print did not hit player. We need this below here. We'll do print distance is plus distance dot toString, and then we'll do print actual distance is, and then we'll go ahead and copy this guy. Let's load this up. Hit play. If it'll load, there we go. Okay, I'm gonna go ahead and turn this guy off real quick. Drag in an enemy. I can open the console. Okay, so it didn't hit the player. That's good. The distance is whatever the actual distance is. Okay, so what right off the bat I noticed that our distance is a negative value, and we want to get the actual distance here. So we'll do math f dot absolute speed times time dot delta time. Okay. Okay. Um, Let me pause this scene here and see what's going on. So this is the distance, and this is what the actual distance is. So as you can see, they're extremely close to each other, and because of that, they are it's making this get called almost every frame. So what we'll do is we'll make a new method, and we'll call it if not close to. Okay, and then we'll make this a boolean, a private bool close to, and then we'll call this B, and we'll call this A. Just some generic variables, and then we'll go ahead and do we'll do return math dot absolute value between A minus B minus and then we need a threshold here. So let's say our threshold would be 0.1. Okay, so this will return true if the distance between A and B is less than 0.1. It means it's close to. If the distance is greater than 0.1 or equal to it, then it's false. Let's go ahead and check it out now. Alrighty, now we are able to move. Jump. Okay. Not quite. Okay. Let me go above here. We'll do a check to see if it actually did hit the player. I know it did because it calculated this, but I always like to see the debug just in case. So right in between here and distance is 0, that's where it hit the player, because we don't have a debug saying it hit the player. We just have a debug saying if we didn't hit the player, so we'll just ignore that frame if we hit him. So, what we'll do now is we'll remove this debug here, because it'll get kind of sloppy when we have more than one enemy spawning in. We'll go ahead and re-enable our spawner. We'll hit play. So as you can see, the ball just it jumps when it hits the other guy, or it'll change direction. Come on, I snake at this game. Alright, just because I suck, I'm just gonna put in my health to something a little more favorable towards my side. So that guy hits me, you can turn around, he turns around. If I can get them to hit each other. They just do not want to seem to hit each other. Oh. And okay, they hit each other and the ball jumped, which is good. or they'll change direction. So now we've got a little bit more complex enemy behavior. This video is getting kind of lengthy, so I'll end it now.